Galena mineral. Galena is a lead sulfide mineral with the chemical formula PbS. It is one of the most important minerals for the extraction of lead and often contains significant amounts of silver. Here are some key details about galena. Physical properties. Color, lead gray. Streak, lead gray. Luster, metallic. Diaphaneity, opaque. Mohs hardness, 2.5 to 2.75. Specific gravity, 7.4 to 7.6. Crystal system, isometric, cubic. Cleavage, perfect in 3 directions, forming cubic fragments. Occurrence. Galena is often found in hydrothermal veins formed at low to medium temperatures, often in association with minerals like sphalerite, fluorite, and calcite. It can also occur in sedimentary rocks as a replacement mineral. Uses. Lead production, the primary source of lead, which is used in batteries, radiation shields, and other industrial applications. Silver extraction, significant source of silver when present as a trace element within the galena. Collecting, due to its well-formed crystals, it is also popular among mineral collectors. Notable localities. USA, Missouri, Lead Belt, Idaho, Coeur d'Alene District, Illinois, Mississippi Valley-type deposits. Other countries, Germany, Australia, and Peru. Environmental and health concerns. Lead is a toxic metal, so mining and processing galena must be managed carefully to avoid environmental contamination and health hazards. Formation of galena mineral. Galena, the primary ore of lead, forms through a variety of geological processes, typically in hydrothermal veins, sedimentary deposits, and as a secondary mineral in metamorphic rocks. The formation of galena is a fascinating aspect of mineralogy, involving intricate geological and chemical processes. Hydrothermal veins. Hydrothermal activity. Galena often forms in hydrothermal veins where hot, mineral-rich fluids move through fractures in rocks. These fluids are typically generated by the cooling of magma or by the circulation of water heated by geothermal gradients. As the hydrothermal fluids ascend through the Earth's crust, they cool and precipitate minerals, including galena, within cracks and voids in the host rock. Temperature and pressure conditions. The temperature range for the formation of galena in hydrothermal veins is generally between 100 degrees Celsius and 300 degrees Celsius. Pressure conditions can vary, but the presence of galena is common in environments with moderate to low pressures. Associated minerals. Galena is often found alongside other sulfide minerals such as sphalerite, ZNS, chalcopyrite, CuFeS2, and pyrite, Fe2. Non-sulfide minerals like quartz, calcite, and fluorite are also commonly associated with galena. Deposition mechanism. The process involves the reduction of sulfate ions in the fluid to sulfide ions, which then combine with lead ions to form galena, Pb superscript 2 plus S superscript 2 Pbs. This deposition often occurs when the hydrothermal fluids encounter changes in temperature, pressure, pH, or redox conditions. Sedimentary deposits. Mississippi Valley-type (MVT) deposits. One of the most significant settings for galena formation is in Mississippi Valley-type (MVT) deposits. These deposits are typically found in limestone and dolostone formations. MVT deposits are formed by the migration of basinal brines, salty waters, through carbonate rocks, which dissolve lead and sulfur from the surrounding rock and deposit galena in open spaces such as cavities and fractures. Diagenesis. In sedimentary environments, galena can form during diagenesis, the process of sediment turning into rock. Lead can be mobilized by circulating fluids and then precipitate as galena within the pore spaces of the sediment. Ore formation. The lead ions in solution are often derived from the weathering of pre-existing lead-bearing minerals or from deep crustal sources. These ions are transported by fluids and eventually precipitate as galena when they encounter reducing conditions or react with sulfur-bearing compounds. Metamorphic rocks. Contact metamorphism. Galena can also form in metamorphic rocks, particularly in contact metamorphic zones where hot magma intrudes into carbonate-rich sedimentary rocks. The heat and fluids from the magma cause chemical reactions that can result in the formation of galena. Regional metamorphism. During regional metamorphism, which affects large areas of the crust, galena can form as a secondary mineral due to the recrystallization of lead-bearing minerals under heat and pressure. Key factors influencing galena formation. Geochemical environment. The availability of lead and sulfur is crucial. These elements must be present in sufficient concentrations in the hydrothermal fluids or basinal brines. Reducing conditions, low oxygen environments, are necessary to stabilize sulfide minerals, promoting the precipitation of galena. Fluid pathways. The permeability of the host rock and the presence of fractures and faults significantly influenced the movement of mineralizing fluids and the deposition of galena. Temperature and pressure. The specific conditions of temperature and pressure determine the solubility of lead and sulfur in the fluids and the efficiency of their precipitation as galena. Environmental and economic significance. Economic importance. Galena is the primary source of lead, which has numerous industrial uses including batteries, radiation shielding, and various alloys. The presence of silver within some galena deposits can also make them valuable sources of this precious metal. Environmental impact. Mining and processing galena must be carefully managed to mitigate the release of lead into the environment, as lead is a toxic element with significant health risks. Understanding the formation of galena is not only important for economic geology and mining but also provides insights into the geological history and processes that shape the Earth's crust. Properties of galena mineral. Galena, the primary ore of lead, is renowned for its distinctive physical and chemical properties. Understanding these properties is essential for mineralogists, geologists, and those involved in the mining and metallurgical industries. Here, we delve into the various aspects of galena's properties, from its physical characteristics to its chemical composition and environmental significance. Physical properties. Color. Galena typically exhibits a lead-gray color, which is characteristic of many metallic minerals. This gray hue is due to the presence of lead sulfide. Streak. The streak of galena, which is the color of the mineral in powdered form, is also lead gray. This consistency in color between the mineral and its streak is a useful identification tool. Luster. Galena has a metallic luster, giving it a shiny, reflective surface similar to that of fresh-cut metal. This property is a key indicator of its metallic nature. Diaphaneity. Galena is opaque, meaning that it does not transmit light, even on thin edges. This is typical for many metallic minerals. Hardness. On the Mohs hardness scale, galena has a hardness of 2.5 to 2.75. This makes it relatively soft compared to many other minerals, allowing it to be scratched easily with a knife or even a fingernail. Specific gravity. Galena has a high specific gravity, ranging from 7.4 to 7.6. This high density is due to its lead content, making it one of the denser common minerals. Crystal system. Galena crystallizes in the isometric, cubic, system. Its crystals are usually cubic or octahedral, and well-formed cubic crystals are common. Twinning is also observed in some crystals. Cleavage. Galena has perfect cubic cleavage in 3 directions at right angles. This property means it breaks along flat planes, forming cubic fragments. Chemical properties. Chemical formula. The chemical formula of galena is PbS, indicating that it is composed of lead, Pb, and sulfur, S. Composition. Pure galena is 86.6% lead and 13.4% sulfur by weight. However, natural galena often contains trace amounts of other elements such as silver, antimony, and bismuth. These impurities can affect its properties and economic value. Reactivity. Galena is relatively stable under standard conditions but can oxidize to form lead sulfate, anglesite, or lead carbonate, cerusite, when exposed to weathering. These secondary minerals can form as a result of the interaction of galena with oxygen and carbon dioxide in the environment. Optical properties. Reflectance. As a metallic mineral, galena has high reflectance, meaning it reflects a significant portion of the light that strikes its surface. This property is useful in identifying galena in hand samples and in reflected light microscopy. Opacity. Due to its high opacity, galena does not transmit light, even in thin sections. This is an important characteristic when examining polished sections under a microscope. Mechanical properties. Tenacity. Galena is brittle, meaning it breaks or powders easily when subjected to stress. This brittleness is due to its relatively weak atomic bonds. Cleavage and fracture. The perfect cubic cleavage of galena results in its characteristic breaking patterns. When it fractures, it tends to break along these cleavage planes, producing smooth, flat surfaces. Thermal properties. Melting point. Galena has a relatively low melting point for a mineral, around 1114 degrees Celsius. This property is significant in metallurgical processes where galena is smelted to extract lead. Thermal conductivity. As a metallic mineral, galena has good thermal conductivity, meaning it can conduct heat efficiently. This property is typical of minerals with metallic bonding. Electrical properties. Electrical conductivity. Galena exhibits metallic conductivity, allowing it to conduct electricity. This property is due to the presence of free electrons in its crystal structure, typical of metallic minerals. Environmental and health considerations. Toxicity. Lead is a toxic element, and galena, being primarily lead sulfide, poses health risks if not handled properly. Inhalation or ingestion of lead dust can lead to lead poisoning, which affects the nervous system and various organs. Environmental impact. The mining and processing of galena must be managed carefully to prevent environmental contamination. Lead can leach into soil and water, causing ecological damage and health hazards to humans and wildlife. Remediation. Modern mining operations often include measures to mitigate the environmental impact of lead, such as proper waste disposal, soil remediation, and water treatment systems to prevent contamination. Economic importance. Lead production. Galena is the most important ore of lead, which is used in numerous applications, including batteries, radiation shielding, and various alloys. The extraction of lead from galena is a major industrial process. Silver source. Some galena deposits contain significant amounts of silver, making them valuable not only for lead but also for silver extraction. Silver is often recovered as a byproduct during the processing of lead ore. Historical use. Historically, galena has been used for lead production since ancient times. It was also used as a source of silver in various cultures. Summary. Galena's distinct physical and chemical properties make it a crucial mineral in various industrial applications. Its metallic luster, high density, and perfect cleavage are key identifiers, while its chemical composition and reactivity influence its economic value and environmental impact. Proper handling and processing of galena are essential to mitigate health and environmental risks associated with lead. Understanding these properties helps in the efficient and safe utilization of this important mineral.